question 25, we're given the following graph here, where we have time against normal level, and we're told that this graph represents how a factor in the internal environment of a person changes and then is returned to a normal level. Okay, so we can see from this description of change following return and then a subsequent return to normal level that this is describing homeostasis, which is the maintenance of a constant internal environment through corrective measures, i.e. potential negative feedback loops, to prevent the deviation of a particular factor from the normal level. So we have a deviation from the normal level from 1 onwards, and then after the peak at 2, this begins to fall to 3, and then to normal levels. Okay, we're then asked, if a condition makes the homeostatic mechanism, i.e. the mechanism of homeostasis, less responsive, how would the graph be altered? So we have a range of options, A through F, describing changes to points 1, 2 and 3 labelled on our graph. So before we have a look at this, it's probably best to hypothesize what a less responsive homeostatic system would look like. So after we have our change, our initial change, it would take more time for the return to normal to happen, since our system is less responsive. So, for instance, there would be a greater increase before the homeostatic mechanism kicked in, so it would take longer for the mechanism to kick in, at which point the peak level of our raised factor would be considerably higher in the case of our less responsive response. So we have 2 at a higher level than 2 here. And then we move on to return to normal levels. So we can have a look at our options. 1 wouldn't be any earlier, so we can get rid of that. 1 wouldn't be any less steep, in fact it would be just as steep. 2 would not be earlier, in fact it would be later. 2 would be higher, as there is a higher peak before which the homeostatic mechanism can control things. That, for instance, is why diabetic patients who can't produce the controlling blood glucose level hormone insulin tend to have higher blood sugar levels, because there is a less responsive homeostatic mechanism. Moving on to E, 3 would not be any steeper. There's no reason to believe that this less responsive homeostatic mechanism would be faster at returning to normal levels. And finally, F would not be earlier, 3 would not be earlier, it would be later. So we have our answer that option D is correct. And in fact, this graph that we've drawn here might be unrepresentative. Over time, this cumulative unresponsiveness to changes in the factor level might eventually lead to a normal level being slightly increased, as seen here. So this would model, for instance, what a diabetic's blood glucose level would look like relative to a normal individual. So we can say our answer is D.